from this point. So router solicitation is the message, and router advertisement advertisement is an response to that. Okay, so you can say like it's like a question and it's like a answer. Okay, so PC1 is asking who is my router in our network, who is router who can help me to get the IP addresses. Okay, this PC need the IP address, so only router can help. Any IPv6 IPv6 enabled router can provide a IPv6 address to the client machine. Okay, but provided it should work as a IPv6 router. Okay, so as of now it is not working as a IPv6 router. Guys, if you have yesterday's discussion understanding, there is one command that we are missing right now, and because of that this router is not acting as a IPv6 router. It is acting as a IPv4 router, but not as a IPv6 router. Anyone remember that command?
We need to enable on interface IP.
That's done actually. This command
OSP.
IPv6 unicast routing, because by default IPv6 routing is not enabled. We need to enable with this command. Once we run this command, you may see this show IPv6 interface f0/0. It has joined this group ff02 colon colon 2. If I remove this command, control A, no, and again I check this output, you will see this group has been removed. Oh, what happened here? Let me check again. So ff02 colon colon 1 and ff02 colon colon 2, these two multicast groups are required to be working as a IPv6 router. ff02 colon colon 2 is specifically for IPv6 router. Let me write it here. ff02 ff00 ff02 colon colon 2. Okay, this is all IPv6 router group. Okay, and that ff02 colon colon 1 is all IPv6 device. So all computers are participating in this multicast group, PC0, PC1 as well as router 1. But ff02 colon colon 2, only router is participating in this group. So when we run this command, when we try to access a IPv6 enable auto configuration IP addresses, so we can receive this addresses from router 1 because it's now working as a IPv6 router. Because when this PC1 sends a router solicitation message, when we click on this, it sends a router solicitation message, and this router 1 send a router advertisement message, and it gives that my address is 2005 AB1. Okay, and the rest of the address you can take from your MAC address. So this rest of the address has been assigned from the MAC address. Okay.
So no need for DHCP on
Uh,
LAN interface, right?
for IPv6 we have this provision. So without DHCP also we can get the IP addresses. Why this has been given? Because means we want to keep the devices very lightweight. This is computer actually, but suppose we have a LED light as a client device, and we want a IP addresses on that LED light. Okay, so with a very lightweight protocol we can have a IPv6 address on the client machine. So this may be the idea behind this auto configurations. Okay, and even though it can go to the means gateway address is also assigned there, so via gateway it can reach to the rest of the networks as well. Okay, So
So
let's.
Samir, in real scenario, like
Hmm.
if we are going to implement IP version 6, so
Hmm.
it is best practice that first we configure the router as a IP version 6 router, then it
Hmm.
will be automatically assign all the devices IP v6.
Yeah, we cannot say best practice. It may be dependent on the means like a network to network, but this feature we should be aware of, that auto configuration feature is there and DHCP features is also there. Okay, so we can go without
Okay.
DHCP. Okay, so if suppose there are like hundreds of devices and in a programming itself they have configured that auto configuration with the help of auto configuration they can get the IP address. So it will become very easy on the client side to get the IP addresses. Okay, this is done here, but if you check on the router 2 or the site 2, the same command show IPv6 interface f 0/0, you may see this ff02 is ff02 colon 1 is there, but ff02 colon 2 is not available. Okay, because we have not run that IPv6 unicast command here. Okay, so guys, I'm going to show you now how we can enable this OSPF routing here and what problem we will face on router 2, and just by running that command we will be able to resolve that issue. IPv6 OSPF, not OSPF, router OSPF1, and we need to give the router ID that we have yesterday also discussed, because we don't have any 32-bit address on the interface, so we need to give it manually. So 1.1.1.1 I'm giving here, and then we need to enable this IPv6 OSPF process on an interface by interface basis. We cannot give it on the network by network basis here. Okay, so we just have two interfaces and we will enable it on that those two interfaces here. IPv6 OSPF1 area 0. Let me repeat it now with f0/1. Done. So both the interfaces, I've enabled it. Now if you check one more time, guys, we have this one more group joined by this f0/0, and even f0/1 also joined that group. Okay, so guys, what this group represent? Second, what this group represent? ff02 colon 5. If you have paid attention in our OSPF discussion, what
Enable
to
the
224.0.0.5 was the number, right? 224.0.0.5, the multicast number. Guys, anyone remember that number? That IPv4 multicast address number. So likewise, we have ff02 colon 5 in case of IPv6. Is there any similarity, right? So ff02 colon if I run EIGRP, can you predict any multicast group which could be a multicast group if I run EIGRP instead of OSPF? Shijesh, you understood my question, Madhu, Prashmi?
I believe that the network address is same and host address is different, like ff02 colon 2 and ff02 colon 5.
This is these all groups represent some meanings. These two are already I given. ff02 colon 1 means all IPv6 device. ff02 colon 2 means all IPv6 router groups. Okay,
Right.
they have joined this, and after running OSPF, we join one more group, ff02 colon 5. So suppose instead of OSPF, we are running EIGRP. So what group they would have joined here? I mean to say interface. ff02 colon colon 10 is not there in hex value, so we will have A here, ff02 colon colon A. Are you guys with me on this?
Not understand.
Rashmi and Shrijesh, you got some idea on this? Hello.
Not actually, Samir.
Okay, okay. I'll try to explain these things. So see, whenever we have a when we run OSPF, you know, hello packets are shooted from that interface where we have enabled the OSPF, right?
Right,
And the time span is 10 seconds, right?
right,
Every 10 seconds we are sending hello messages. So if this interface is also listening on the OSPF multicast address, then only this hello packets will be entertained, right?
right,
So router 1 already we have enabled OSPF, so it is listening on a multicast group. Which group? ff02 colon colon 5. So when router 2 will get enabled for OSPF, they will send a, this router 2 will send a hello messages on the multicast address ff02 colon colon 5. Means the destination will be ff02 colon colon 5. So it will get cached on this interface.
mm-hmm.
If this interface f0/1 has not joined ff02 colon colon 5, this hello packets will go on west because the destination IP address is ff02 colon colon 5 for the hello packets. So it will be listened by this. It's like a, you are addressing me like Samir, listen, so I'm listening to that because that's the address I'm joined with. Okay, but if I am not joined with Samir, and suppose we are in the classroom and you are calling Samir, please listen Samir, but my name is not Samir, so then I'll not listen. Likewise here, this multicast group is joined by this router interface, and that's why it is listening on this. And when hello packets are shooted, that will have a destination multicast IP address ff02 colon colon 5. Or better, I'll show you in a simulation if it is possible in IPv6. I'm not sure about. Let's check. OSPF is there? Yeah. I guess this OSPF IPv6 simulation capture won't work properly on this. Maybe newer version is having this capacity, but my older version, this Cisco packet tracer is not working with that. I cannot show you this. If it is IPv4, we can see, but in IPv6, we cannot see this. Okay. So if we can see this, definitely it will be ff02, means when packet is given. See, let me show you what will be there in the hello packet. Hello packet. Okay, source IP address is your link local address. Link local address. Okay, and destination IP address is a multicast IP address. Multicast IP address. So in our case, it is ff002 colon colon 5, like this. Okay. So on the similar line, I was asking you that if instead of running this IPv6 on OSPF, if I would have run it on IPv6 EIGRP, what could be the multicast address joined by these interfaces? Okay, so IPv6 interface f0/0. So this group would have replaced by ff02 colon colon A instead of 5. Why A? Because A means 10, and EIGRP group is multicast group is 224.0.0.10 in case of IPv4, and in case of IPv6 it is ff02 colon colon A.
Okay, so you want to say that in every protocol they have some different multicast address, like in OSPF, the multicast here is FF02
colon
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 for
5.
5. Mhm.
Okay, got it. And in
So
EIGRP it would be A.
A, and
So
if it is RIP version 2 or RIP NG, then 9. Like
okay,
this, it is sync with each other.
so
Okay.
that is the fixed value, or it
Yeah,
can
this
be.
is defined in the RFC itself.
Okay, got it.
Means this is OSPF version 3. OSPF version 2 is IPv4 and OSPF version 3 is IPv6. So it is defined in that RFC itself. So
All
whether
right,
you are running a Cisco router or Juniper router, these values will be constants there.
got it.
Okay. So we ran this OSPF on router 1. Let's do it on router 2 now. So enable show IPv6 route. Only connected routes are available so far. So we'll configure a OSPF now. Enter IPv6 router OSPF1. We need to enable the IPv6 routing process here. So unicast routing is the command for that. Then we'll run this command and we need to give the router ID. Then this is the router ID. That's it. Then we need to enable the OSPF on interface by interface basis. So two interfaces we have on site 2 as well, F00 and F01. Command sequence will be similar, IPv6 OSPF 1 area 0, and similarly IPv6 for F01 we need to run the same command. We should have a neighbor relationship form, but it's not forming the neighbor relationship. Let me check. Is there any issue with this? Test.
I believe the interface F0/1, the site 1 and site 2, both IP address has same.
No, site 1 I have kept 2 and site 2 I kept 2. Means site 1 is 2005 AB 12.1 and site 2 has 2005 AB 12 colon 2. So connectivity is there and no problem. This it took some time, but now it has been established. So I believe this routes are also available, and you can see here the routes are also available, and it is coming via this addresses, link local addresses. So this link local address plays important role in hello packets and plays important role in updates as well. Okay. So the neighbor relationship has been formed on this link local address. So if I see this show IPv6 OSPF neighbor, you'll see this neighbor is there with the neighbor ID with the router ID, but actual hello packets are coming through this link local address, the link local address assigned on this interface. Okay. So this routing is complete. Let me check the end-to-end connectivity. I'm going to give the IP address on PC2 now. Let's take it auto configuration. What I'll do, I'll take this address from command prompt IP config, give us the IPv6 address. Is there any command for that? IPv6 config is there. So let me check that. IPv6 config, and this is my address. Ping Okay, so I'm able to ping to that far side device. From PC0 I'm able to connect with PC2 now. Okay, so any doubts so far on this, the how we can do a routing in this, and how this address assignments are done, and how we can configure the basic configuration of IPv6? Any doubts so far?
No, I believe that's fine.
Okay, then one of the important process that we need to understand here that we have not discussed yet is NDP. NDP stands for Neighbor Discovery Protocol. Okay, so in case of IPv4 we were using ARP. Okay, but we don't have ARP in case of IPv6, so we use NDP instead of that. So guys, IPv6 is a layer 3 protocol, but on layer 1 and layer 2 it is as it is. We are still using Ethernet, we are still using same signaling systems, we are still using MAC addresses. Okay, so to have this communication fulfilled, we need MAC addresses to be populated in the NDP cache. Okay, just like a ARP cache, here we have NDP cache. Okay, Neighbor Discovery Protocol cache. So how it works, that we need to understand. Okay, so just suppose I want to see the MAC address of this router on f0/0. This interface I have f0/0, and I want to see the MAC address, or I want to get the MAC address of this interface f0/0. How I can get it from PC0? I'm there on PC0 and I want a MAC address, because without MAC address I cannot form a frame and I cannot send the data over the router. Okay, so this command I shown you, show IPv6 interface f0/0, and you see here these two numbers are there. This is called as solicited node multicast group, SNM. Okay, so what is the role of this? Let me write it here. These are like lots of acronyms. Solicited node multicast group. Okay, in short we can say SNM group. Okay, so suppose PC0 wants to communicate with this IP address 2005 AB colon colon 1. Okay, so how this will be calculated, let me tell you. So this controls it. This is my target IP address. So whenever we communicate with any computer, we first has to know the IP address, then we can figure out the MAC address as well. Okay, so this address I know. From this address we can find out the SNM group. How this SNM group will be calculated? If you analyze these two SNM groups, there is some commonality between, some common things in between these two groups. FF02 colon colon 1 colon FF. This portion is common in both the addresses. This portion is common in between both the addresses. Okay, the remaining portion is change. It is subjected to change. This is subjected to change. Okay, so this common portion I'm copying here. Okay, let me copy it. Copy. Okay, and in this the last 24 bits are calculated from the address, from the this IPv6 address. So if I write this address in a full format, it would be like this: 2000 2005 colon A colon B colon 1 colon 1 colon colon 1. If I expand this, it would be like this: 0 colon 0 colon 0 colon 1. Okay, if I expand this last 24 bits, it would be like this. Control Z. It would be like this: 0 0 0 0 colon triple 0 1. So these last 24 bits are the important one. Okay. Okay. This I have to write it here in the SNM group. So 00 is the trailing one. I cannot remove that, but I can remove the this portion. I can remove this portion. I can remove because these are the leading zeros. So leading zeros I can remove and I can replace it with one. Same number you will see on our SNM group. Okay. This is for this global scope address. Let's check this same thing for the link local address as well. So let me.
Samir, sorry to interrupt you.
Mm-hmm,
Uh, the after the below the SNM,
mm-hmm,
you have write it down 2005 colon A colon B colon 1 colon 1, right?
mm-hmm, mm-hmm,
And below that, that is 2005 colon A colon B
mm-hmm,
colon 1. Now
mm-hmm.
you have mentioned 30. I believe it will be 20 because
Uh,
we have
this two zeros
no
or this three zeros.
just above that.
Yeah, this 30 you mean to say, right?
No. Uh, uh,
See this
yes.
0:1. I can write it like this. This zero means all four zeros
No,
because it's a.
my question is different. Uh,
Mhm,
Below the SNM, you have
mhm,
mentioned 2005 colon A colon B colon 1 and double colon 1.
mhm.
Below that, you have mentioned 2005 colon A colon B colon 1, and there would be 20, not 30, I believe, because there are two colon between 1 and 1.
Here we have two colon, and because of that, you are thinking like this should be double zero instead of 30,
Right.
right? But actually, the case is when we represent double colon, when we have to represent multiple zeros, we are not sure about how many zeros are there. So whether it is three zeros or 20, how we can find out? See, how many groups are there altogether in IPv6?
Uh,
Total
but,
eight groups, right?
right.
Total eight groups. So if I'm representing double colon, it means I
So,
have four groups represented this side and one group represented this side, means 4 plus 1 is like a five groups. So five groups are there in our representation of this numbering, right?
mhm.
So how many groups are missing from there? 8 minus 5 is 3.
Okay, but yesterday when we put in the IP version 6 address, if
Hmm.
there is uh, 4 times 0 and there is a 4 times 0, we just make a single column for 4 times 0 and single column for 4 times 0.
See, this is how it works actually. So
Mhm.
if suppose I have a 2005 00, okay, 10, let me write it here. Suppose this number goes like this: 2000 colon 0 colon 0 colon 1. Okay, then again 0 colon 0 colon 0 and then 1. One second, let me write it like this. Okay, so can you put double colon twice? You can't put it because then you will be we will be in full confusion, and even operating system will be in confusion where this zeros are there and how many zeros will be there. So you can put double colon only once. You got the point. You can have double colon only once and it replaces the number of zeros. So if you have five groups and three groups are missing, because total we have eight groups, so
Right.
this represents three zeros here. Okay, so this double colon feature you can only use once, and wherever you find it, those many groups will be sandwiched in between or replaced by double colon or whatever we are we are not representing on this numbering.
So in IP version 6, we use a double colon only a single time. Not
Only single time, otherwise it will be a ambiguous situation or a doubtful situation.
okay. Right.
Okay, so we are, I'll remove this part. Okay, so this is the SNM group for this number, this number. Now let me show you one more thing, one more SNM group. So I'm going to copy this SNM group now, and how it came up, we will try to discuss that thing as well. So this is another SNM group we have here. Control C. It not copied correctly. Copy, get it paste. Okay, how this SNM group came up. So for it came up from this number actually. So let me copy that number as well. Copy, paste. So what I told you, SNM group came up with this last 24 bits, and the initial number is FF02 colon colon 1 FF. Okay, up to this portion, and this portion represent the last 24 bits. So this last 24 bits, if you compare it from here, it is similar. Why 24 bits? Because see, this 6 character represents 24 bits. One character, one hex character or one hex value represent 4 bits. So 6 hex value represent 24 bits. Okay. So this is how this SNM groups will be calculated. Suppose I want to, means PC0 wants to get the MAC address for FE80 FE80 2001 CF99. This number we have to take the MAC address. We have to take the MAC address of this IPv6 number. Then we will send a neighbor solicitation message. It's called as NS message. NS message, neighbor solicitation. Let me write it here. Neighbor solicitation message, and in it, this will have a source IP address will be the PC0's IP address, and the destination IP address will be FF02 colon colon 1 FFEC7D01. This number SNM group will be destination IP address. That's a multicast IP address. So guys, if destination IP address is a multicast IP address, what will be the destination MAC address? Guys, you understood my question? Shrijesh, Madhu, Rashmi. If you have a destination IP address as a multicast, what will be the destination MAC address?
So it's a router interface MAC address.
Actually, MAC address we don't know. That's why we want a MAC address. The whole purpose of this NDP is to get the MAC address. But if you are sending it on any, in general, I'm asking you, in general, if we send a packet on a multicast IP address, its MAC address is also a multicast MAC address. That's defined in the protocol itself. So NDP protocol we have, wherever we have SNM group, okay, multicast group. So the destination is multicast MAC address, also multicast MAC address. Means destination is multicast IP address. Means layer 3 we have, uh, in a layer 3 we have destination as a multicast IP address. This is multicast IPv6 address. So your layer 2 will also be a multicast MAC address. What exactly it is, I'm not sure about, but it's for sure that that will be a multicast MAC address. Okay. And if you have a multicast MAC address, how your switch is going to treat with it?
Multicast only.
See, whenever switch get a frame who has a destination as a broadcast and a multicast, switch doesn't know who has joined this group, right? So switch has to flood this packets to the rest of the all interfaces. This is the default behavior of the switch. You guys are aware of this? I mean, switch discussion, we discussed about this. Three times the flooding happens. One is unknown unicast, one is for broadcast, and one is multicast. So unknown unicast, if the switch doesn't aware of the MAC address where it is placed on the which interface it is placed, that time also flooding happens. If the destination MAC address is FFF 12 time F, that time also flooding happens. And if the destination MAC address is a multicast MAC address, that time also flooding happens. How the switch will recognize this MAC address is a multicast MAC address? So multicast MAC address always starts with 01 as a hex value. Okay, and when it hits to the switch will directly forward it to the rest of the all interface. So suppose PC0 is sending this neighbor solicitation message, and the destination MAC address is this one. Destination multicast IP address is this SNM group ff02 colon colon 1 7001. Then it will have a destination as a multicast MAC address, and it will be flooded on this port as well as this port. But PC1 will simply ignore this. Reason, PC0 has not joined this group, whereas router 1 has joined this group, and router 1 will respond back to PC0 with the MAC address, and that will be unicast MAC address. And that time PC0 will realize that this particular this particular IPv6 address has this particular MAC address, whatever MAC address we have on router 1, and then packet will be forwarded to router 1. Likewise, PC1 has their own SNM groups, okay, and PC0 has their own SNM groups. So when PC0 wants to communicate with PC1, it will send a message on that SNM group, okay, and it will take the MAC address from the neighbor advertisement message. So neighbor solicitation is again a question, and neighbor advertisement is a answer for that. Okay. Neighbor advertisement. Okay. Madhup, you understood this, Shijesh?
Yes, this is little complicated, but it will be
Ha.
depend upon the practice.
No, actually, really it is complicated, but that's how they have designed it. Means
Mhm.
they had totally omitted the usage of that broadcast addresses, and to bypass that broadcast addresses, they made it little complicated. But the intelligence they have made on this.
Mhm.
Okay, so this is how this neighbor discovery protocol works, guys. You go through it once again, because this also means like it, to understand this, I also watched different YouTube videos and all this books I read, and then I understood. So it's not that common that in the first go we try to interpret it in a correct way, maybe, but I tried to make it more simpler. You go through the video recorded session once again, you may get this idea more clear, and do the practicals, then it will become more clearer to you.
Right.
Okay, so uh, this is all about IPv6 we have to discuss. One point I yesterday which I discussed, probably you may not have understood it correctly, so I'll repeat that point. Site local address. So this site local address is like a private IP address, and it's always starts with FD00. Okay, and it is followed by global ID, and it is followed by subnet ID, and then we have interface ID. So this global ID is constant throughout the company, and subnet ID keeps on changing department by department or VLAN by VLAN according to our organizational structure. Okay, and a few more important addresses are there that we need to understand in IPv6. This address, where I mentioned this somewhere. This is one of the important address. So when you have a loopback IP address in IPv4 as 127.0.0.1, whereas in IPv6 we have this colon 1 as a loopback IP addresses. Okay, so here all class A range has been vested on this, but here only one IP address is utilized. So they learn from their mistakes in the past when they implemented it on IPv4. Now they have only used on colon 1 IP address. Rest of the all addresses are not vested on this. Okay, so these are few addresses. Then multicast group also you have understood, it always starts with ff02. Okay, when we start to in a website access, we have to give this in a square bracket. Let me show you. So let me put the address on the server. We'll go to desktop. Address I'll put here like 2005 colon a colon b colon 2 colon, let's take 100 here, 64, control C, control V. It should be gateway address, that's 1. And let me try to access this. First I'll just ping from here. Yes, it's 100 only, so it's reachable. But if I want to access it over the web browser, okay, in packet tracer nowadays it works in sometime it may not work, so we have to use this way. Okay, it should be bounded by this square bracket, and then it gives us the output. Okay, then few more small things are there in a IPv6 discussion that I pointed out in my document. You just go through it. Okay, guys, I'm going to start this new discussion on this SDN. I believe most of the points are clear on IPv6. Okay, you do the practicals. When you face any issues, you can drop a mail on this. Okay, this IPv6 packet also I'm going to upload in my PKT file, so as a reference you can keep it. Okay, so where it is, IPv6 lab 3. Let me upload it. Maybe I'll forget afterward. So where we have to keep it, PKT file. Okay, so let's start our discussion on SDN. Shrijesh, any exposure on SDN? Madhu?
Yeah, I have learned about some software defined network that uh, we can assign some policies on the management
Mhm,
desktop, wherein that will be automatically changes the if
mhm.
there would be any malware or something happen, that would
Mhm.
be defined by the intelligence and all these things.
Okay, okay. And you Shrijesh, any exposure on SDN?
Actually, we are planning to implement.
Okay, okay. So here we will keep us the discussion very light. We just try to understand the overall structure of SDN, what components are there in the SDN. Okay, and implementation part of point of view, I'm not going to show you any practical, but I'll show you from where you can learn more from on this domain. Okay, so first, uh, first of all, we'll just discuss about the theoretical points, and then I'll show you from where you can learn more about this. Okay. So this is one definition I got from the website ONF. Okay. Open Networking Foundation. So they have defined it like this: the physical separation of network control plane from the forwarding plane, and where the control plane controls several devices. So we should be aware what is control plane and forwarding plane first. So last time I believe I have discussed about control plane, forwarding plane, or data plane. Forwarding plane and data plane is similar. Uh, so control plane, if I would give an example on this, it's like a traffic police officers are a control plane, and whatever discussions they are doing, it's like a control plane traffic. But user means data plane or the forwarding plane means like normal people vehicles. Okay. So if suppose we are traveling in a car on the road, so we are falling in the forwarding plane traffic. But if police vehicles are going and they are controlling the road traffic police officers, so that will be considered as a control plane. Both are important, but actually roads are built up for the forwarding plane, means I mean to say the normal people. Okay. So this if you consider OSPF running on multiple routers, so the hello packets are moving from one router to another router. So that hello packets communication, or the updates, LSU, LS update, or LS acknowledgement, okay, the loading stage, this all communication falls under control plane. Okay. And when user 1 try to communicate with user 2, that falls into forwarding plane. Okay. So what it says, like a physical separation of control plane and forwarding plane, where control plane controls several devices. So here one diagram I have made it here, you can see. So if you don't run a SDN or software defined networking, then individual network devices like router 1, router 2, router 3, they will have their own control plane, not the centralized control plane. But if you run as SDN, you will have one centralized control plane. Okay. Means router 1 will use their own brain. Control plane can be considered as the brain of the device. Okay. So router 1 will have its own brain, router 2 will have its own brain, router 3 will have its own brain. They will take a decision accordingly. Okay. They will decide what will be the best path, because they change the LSA messages, link state advertisement, and they figure out the best path to reach to one particular network, and accordingly data will be forwarded. Means they themselves on their own decide how to forward the data from one locations to another location. But if you have a SDN implementation, we will have a controller. That controller decides how these devices should behave. Okay. And we will give a control instructions to these devices, and accordingly they have to behave. Okay. So this communication happens with the help of open flow protocol. This protocol is called as open flow protocol, and this is called as southbound means controller to the network devices. But how the controller will be controlled then? Because controller is not a human being, actually it is a Linux based operating system. So it has to be controlled by the network administrator. So network administrator individually will not come give the controls uh, to the devices. It will be controlled, these devices will be controlled by the controller, and controller in res- uh, will be controlled by a a program, Python or VB based program, and that program is written by the network administrators according to the requirement of the organizations. And that time we use Java or RESTful API protocol to give the instructions, and this is called as northbound means if you consider a controller in a center place, this upper directions is northbound and this lower direction is a southbound. Okay. In in addition to that, we have eastbound traffic and westbound traffic also. That's like a controller 1, controller 2, controller 3. So if any one of the controller goes down, we will not have a single point of failure. We will be having another controller to take over the control of the devices of device 1, network device 1, or router 1, router 2, switch 1, switch 2, firewall 1, firewall 2. All will be handled by the controllers. Okay. And this is not the fictitious actually. Nowadays Google since 2010 is implementing this SDN. Microsoft also has implemented SDN. NSA has also implemented SDN. If you Google it on the YouTube, the Open Summit, Open Network Summit, I guess this is the title for that. Let me check. I'll show you. You can research more on this. Open Network Summit. Okay, YouTube. So whoever has implemented SDN, they discuss their case studies, how they are implemented, what benefits they draw from SDNs. Okay, because see, Google and Facebook and Microsoft, these like a big enterprises, they second they cannot survive with the traditional networking. See, Google has to deal with the petabytes of data transmission. It's like a gigabyte, uh, megabytes, MB, GBps, TBps. So like that, they are dealing with the petabytes of transmission. So with the traditional networking, they cannot survive. Means actually, see, storage cost is going down. This The software cost is also going down. This operating system cost is also going down because they have the implementation of cloud and all these things. But this networking part, they are failing because of this vendor dependent networkings like Cisco, Juniper. They have to take from there only. And furthermore, the these devices, these networks are not sufficient for their data flow, because they have designed it from a enterprise business point of view, but their enterprise business is dealing with huge amount of data. So they have to come up with their own type of networking, and that's possible with open networking only. Means uh, like a Linux based operating systems for switches, Linux based operating system for routers, and that's not proprietary, that's open source. I guess Pika 8 is one operating system, Linux based operating system, that we can implement on any of the switch. May not be on Cisco switch, but some other switches are still supporting it. And you can have your own version of STP, your own version of protocols there. Okay, not STP, means any protocol which we want to implement in our infrastructure, that's not yet designed for rest of the enterprises. So according to our enterprise, that Linux customization could be possible, because Linux is a customizable operating system. So that customization is possible there. Okay, so one second, few more things are there mentioned in my document. One pointer I have made here, like a hardware abstraction we do in case of server, like VM installed on Windows based laptop can be migrated to ESXi server. Guys, you have deal with ESXi server before?
No, but I heard about in VMware.
I'll tell you what is that. Shrijesh, you deal with the ESXi server previously?
No.
See, ESXi server and this VMware is not a different. The only thing is VMware workstation is for my Windows operating system, or Windows 7 or Windows 10. But this is for small scale. But if I have a private cloud and I want to run all my virtual servers, like Active Directory servers, and I have like a big enterprise running and like a 15 servers I want to run. So I have a big server with 256 GB of RAM. So I can load this ESXi server as a Linux based operating system, and on top of that ESXi VMware ESXi server, I can run small VMs. Okay, so I can take my VMware workstation operating system like this. You can see this GNS3 VM or this UNL Lite. Okay, I'll I'll export it. I have option to export it. Okay, actually this is here. I don't have this option. Snapshot manage. There is some option like I can export this VM. Okay, and this exported VM I can import in my VMware ESXi server, and whatever feature or whatever software I have installed on that VM, same will be available in my ESXi server. But suppose this laptop is my own laptop, but ESXi server is running somewhere in my data center, and all of us are able to access that server. You guys understood this point? Means that without making change, I'll be able to handle this migration. This migration is very simple, but same thing is not available in networking. Suppose my whole setup is on Juniper router and I want to change this to Cisco routers. So it's not that easy. I have to uh, redo the coding there. Means whatever commands I have to run on Cisco, that similar or possible commands I have to run on it's like a Juniper commands I have to take, and I have to run similar commands on Cisco devices, because the configuration part on Cisco is different, configuration part on Juniper is different. So if we are running SDN, this is very simple. Then we don't have to worry about the vendor dependent part. I believe this is making some sense on this SDN part.
Yeah, as for the ESSI server, we
Mhm.
can run multiple operating system,
Right,
multiple operating virtual machines.
right. And you can copy that one virtual
Yes,
machine from one server to another server, no
right.
problem.
Yeah,
You will
that will
have
be
that
very,
flexibility with you.
yes, yes.
So same kind of flexibility we don't have in network devices. Reason, we are trapped in Cisco, we are trapped in Juniper, we are trapped in blah 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 operating systems, right? So with that independence we are not having in case of networking devices, and open SDN is promoting that part only. Okay,
Samir,
so
I do have a small question on
yeah.
SDN. Like, in in previous scenario, like we are implemented router configuration, switching configuration.
Hmm.
But in like in today's scenario, like the SDN is comes up.
Hmm.
I believe that will be very easy to configure or uh,
Right.
by
uh,
the admin side.
Right. Actually, we use a controller called as Open Daylight actually. Okay, and this configuration become easy, but at the same time, this we have to be familiar with this controllers. Means like interfaces and controllers. Means programming we should be aware of, because all of the things will go through this programming. Okay, so any change you want to make, you have to go through this uh, Python programming or this means this details of the programming we need to understand. Means when we are shifting toward SDN, we should be aware of the networking part as well as the programming part, so that one more overhead will come on the network engineer then.
And how much the weightage for the SDN in CCNA exam?
It's nothing actually, hardly any one question will come that may be weighted at like a 5 points to 10 points, that's it, amongst 1000. In means like a 0.1% or 1% max to max.
Okay.
Okay, so that's means like a here OSPF practicals you will see, VTP practicals you will see. If you are going to give the exam, you will see the practicals on the important concepts like OSPF, spanning tree protocol, or EIGRP. These practicals will be there. Okay. So that's it from my end. I have done almost all things regarding this discussion. IPSLA, you will have a practical on CCNP, so I'm going to skip that part. It's not that big deal. It's very simple to understand when you will see the practicals on IPSLA in the CCNP route. Okay. Guys, you can mail me if you have any queries on the if you have any queries on the practicals. You can take a snapshot, mail me the details. I'll try to respond on that.
So is it our last class?
Yeah, it's a last session. From Monday onward, I believe. I have not been communicated by Ambush, but I believe your new session will start for CCNP.
To whom it will be going with? You or some other?
He has not instructed me regarding this, that you are going to take the session or not.
Okay, I will ask you.
Yeah, you can ask. Yeah. Okay,
Thank you.
guys. Welcome, Rashmi. So, guys, I'm closing the session, and thanks for your attendance in this attending these classes. And uh, your I wish best of luck for all your rest of the career.
Thank you.
Samir, uh,
Yes.
we require that one operating system is there, right, for studying.
Uh, you mean to say this UNL?
Yes, yes.
I have not uploaded it. I'll upload it and I'll mail you the details. Or if you are in Bangalore, you can get it from there also. Or let me upload it. Whoever wants, they will get it. I'll check this Mega Drive. I'll upload there and I'll mail you this details. Okay.
You can use OneDrive also.
I have account on Mega Drive. That's why I'm saying that.
And we will still having the access of that drive, Google Drive,
I have
CCN.
not revoked it yet. You this I'll upload all the for next few days or next 1 month. I believe I don't have any problem to keep it.
Yeah, that would be great because we haven't downloaded all the video yet.
This you can download it. This because why I'm saying so, because
Mhm.
I may not revoke your rights on the drive, but
Mhm.
this if I'm running out of space, I may delete some of the
Yeah,
video.
we will try to download ASAP.
So by the next week, you max to max 1 week at least, I'll be keeping it.
Mhm.
If I'm not running out of space, I'll keep it. Okay.
And do we have any examination practice questionnaire?
As of now, I have not uploaded. Guys, you need to check this with this website. Let me 9tut.com is the website name. Let me show you that. Tut.com. This is very good resource. I have tested this lots of time, but it is free, so it's not assured. But when I gave the exam, this was a useful resource. Here you can see this share your experiences page is there. Okay.
So is it consist all the labs only or some questions?
It gives the exact questions actually in the exam.
Okay.
But the thing is, it's lots of questions. If only like a 50 questions are there in the exam, they will give you 500 questions. So
Hmm.
you have to study a lot from that. It's like a multiple question bank.
Hmm.
Uh,
So
and
networker home is not providing us some questionnaires like dumps and all these things.
you can talk to Ambuj regarding this.
Sure.
He is a good resource on this. Actually, he will guide you how we can take it ahead on this
Okay.
exams.
Okay.
Okay. Okay, guys. Then anything else we can discuss here, or should we close this session?
I'm good.
Okay. Okay.
Thank you
Okay,
so much,
Rashmi.
Samir. Thank you
Welcome,
so much.
guys. Welcome. You will be connected with me. If you have any query, you can ask me. No problem.
Sure. Sure.
Okay. Okay, guys. Bye.
Bye bye.
Good night.
Good night.